Okay, so hi, welcome to my video for my last assignment for this class. Assignment number 6. So, firstly, I'm gonna show you guys the the header file. Okay, so here's my header file. I have my libraries and my template class here. You can see I have everything like the queue, the capacity size, destructor, constructor, um, assignment operator, overload, deep copy, assignment operator overload, then the deep copy constructor. And then I have the print and the get element as well. And dig queue, on queue and dig queue are the two most important ones here too. So I have those ones as well, as you can see. So now I'm gonna show you my HPP file. Okay, so here's my HPP file. So yeah, I made this one. This is like capacity 10, make the queue because it's an array of arrays. And then yeah, so that's like it. I made my destructor and use the way you delete like matrices. And then I made my copy constructor here, as you can see. It's pretty standard. And then I also did my assignment operator overload for setting stuff equal to each other to get the deep copy. Yeah, pretty standard. I just copied the static stuff and copied the dynamically allocated stuff. And then I also made my onQueue function, which is pretty standard as well. Made it a boolean to just to check to see if the size is smaller than the capacity. It won't really matter though because I'm supposed to just like put in 5 and then take out 5, like onQueue 5, and then dayqueue 5 values. And then my dayqueue standard as well. I'm just like taking, I'm just overriding each index. I'm just overriding an index of the array, which is pretty standard to me. Like you take one, override it, so that means that new one, the one you started with, is gone. But and then it just takes the one from right after the index right after it and just overrides the index that you're on with it. So like yeah. Okay, let's use an example. So like if you have let's say you have an array of 0, 1, 2, 3, 4, 5, right? And then that's 6 indices because it's 0 index, but you'll go from 0 to 5, right? And let's say you put in a 3, so at index 3, it's going to be overwritten. I mean, it's always going to be deleted. So that means it'll go from 0, 1, 2, 4, 5, and the array got smaller by 1 as well. So, like, if that makes sense, yeah. And then my get element one is simple. Like it's just basically saying if this if statement is checking to see if it's if the capacity is smaller than the number you put in, or yeah. And then and then it'll make the it'll just set it to basically this is error checking. Like this is if you put like a large number in, let's say like capacity is 10, you put like 21 in, it'll automatically set the number to 9, right? And if you put like 23 in, it'll automatically set the number to 9. If you put 11 in, automatically set the number to 9 because any number that's greater than capacity will automatically be set to the capacity minus 1. And then it'll just return q to that end with n index. Yeah. That's horrible, I think. And then here's my I'll show you guys my CPP file now. Okay, so here's my CPP file. This is how you use use templates to like use them in a file to like actually like my bad, for declarations of the template class. You use it in this manner, and then I put this count here because I'll explain it later. I basically gonna use that count to make sure I don't get a seg fault when I'm printing out the arrays. So yeah, and then so this is just for loops on queuing stuff, like putting stuff in, like just generate, like loading the arrays and stuff, loading the double array, or not double array, my bad, the matrix. Technically it's a matrix. And then this is just printing them out so like you can see them, and then this line is just to the DQ is starting, and then it'll always DQ the 0 index, because if you if you throw in an I there, it'll it'll be weird, because you'll be DQing 0, 1, 2, 3, 4, 5, but every time you DQ it, the number gets smaller, so it'll eventually lead to a seg fault. And then so yeah, you'd be like you'd be accessing out of bounds stuff and trying to delete stuff that's not even in the array anymore. So you gotta DQ the zero index a lot, like over and over again, so you can actually delete this stuff and make sure it's actually in bounds. And then so I deleted the account. I deleted the account by 5 because it needed to be deleted because of the how many times it's being DQ'd. Because you just gotta make sure that the so you don't actually, because like if you don't make the count smaller by like the same amount that you've DQ'd, then the count will try to like print out of bounds stuff, which is bad because it'll lead to a seg fault. Luckily this is a safe environment, but yeah, like those seg faults are like pretty bad. So yeah, and then I deleted an extra one because arrays are 0 indexed. So like because like if you don't delete the extra one, then you'll have like a count equal to 1 here, and that would be an issue, because if you try to index or like throw in a 1 here for the when you see outing the like printing out the queue, it will it'll be bad, because like when if it'll be a seg fault, because you'd be accessing the second element of the array when there won't be any second. There'll only be one left. I printed out 6 and deleted 5. Excuse me. And then so yeah, that's why I deleted an extra one after the 5, and then I just see out at the array or what's left of it. So yeah. I'm not gonna show you guys what, like when you compile it. Okay, slow it down. Actually, I'm gonna make it executable for it. I lied. No, I'm not. I'm just gonna use a dot out. Hold on. Okay, so as you can see, it printed out the first 6 of the of the uh of the arrays of the separate queues, and then I DQ'd 5 from each queue. So I just got left with the last indices of the queue. So you can see like it deleted 5 from each one, because it printed them out first. So yeah, thanks for watching my video, being a part of this.